Remnants of Mayan civilization are being discovered by archaeologists as they dig extensive networks of tunnels into sites. The archaeologists document their findings with hand-drawn sketches. However, sketches are time-consuming, prone to error, and do not truly depict the complexity of the network. Therefore, we propose digitally recreating the tunnels with real-time 3D models, generated by multi-camera SLAM algorithms. Let's go over the 3 algorithms we tried.
It is the extended version of ARP Slam which can handle multiple cameras at the same time. It uses ARP to extract the feature points and try to estimate the camera pose and the relative camera motion. It generates 3D model without using the depth data. It can work with any type of cameras, perspective, fisheye, and omnidirection. This is the Multicamera ARP Slam module. Currently we are getting feeds from 2 cameras, which you can see on the top left and the bottom left windows. Green dots with blue boxes shows the features which are being tracked in those frames. On the right side, it shows the trajectory of the camera, the motion of the camera being calculated from these tracked points. Green and dark blue square boxes defines the camera system. This is another data set with similar 2 camera feeds. The red dots represents the points which are used for estimating the camera pose. The blue crosses represents the keyframes generated, and it accurately gives the path of the camera motion. This gives a trajectory file which contains the camera pose at each keyframe position. With some post-processing, the 3D point cloud can be generated from the trajectory information.
MCPTAM is an extension of PTAM, parallel tracking and mapping, a single camera SLAM algorithm which is designed for multiple cameras that are rigidly connected together into a cluster. The field of view overlaps of the multiple cameras allow full motion and structure recovery, and the wide field of view will capture more feature points in the environment to prevent the system from losing track.
This is the intrinsic calibrator for Taylor camera model. As the camera captures the corners of the checkerboard, shown with the blue indicators, by pressing grab keyframe, the calibrator will grab the current keyframe. After having enough keyframes taken from different angles of the checkerboard, by pressing optimize, the calibrator will calculate the reprojection error, shown in red line if the error is big enough. The save button will save the calibration to a YML file. This is the extrinsic calibrator. It is supposed to generate a map based on the first camera, but unfortunately, we could not make it initialize the map due to errors in the first camera, as shown in the red lines. Because of this error in the extrinsic calibration, we cannot make MCPTAM algorithm to run as well.
Artim is real-time appearance-based mapping that uses RGB and depth data to create a graph whose nodes are the pose of the camera and the edges are constraints between poses. So a graph is generated as the camera moves around and then is used to construct the point cloud in real time. The right window shows the real-time point cloud being generated. The teal line shows the trajectory of the camera. The yellow and green dots are all feature points. If the screen flashes yellow, it means the algorithm is having trouble tracking where it is. If it flashes red, it has lost position altogether, but allows you to go back to a previously recognized point in space to restart the algorithm. The 2 bottom left windows are showing the significance of features being looked at. Red circle indicates features that have previously been located. Green indicates that it is a new feature. Yellow indicates the same but signifies repeated features. Blue indicates features found in previous images. When the bottom left screen flashes green, it means the new loop hypothesis has been accepted. However, if it flashes red, it means it is rejected. As you can see in the end, it's having trouble recognizing its location because of the repeated features found on the lab table charging stations.